All right, guys, back with you here with some more systems. And here we're going to be learning our second strategy, which is solving systems by a strategy called substitution. Something that we've done already in Algebra 1, but this is a little bit different of an application of it. Okay, so let me get into it here, kind of what we're doing and how we would do this. Okay, so solving this by substitution. Okay, so last time we learned graphing, and so this is just another strategy that we can use. And why would we use this strategy? Why do we need to learn another one if we could use graphing every time? Okay, well, like if you look at these equations, right, for us, especially if I was graphing this by hand, these would be a lot of work for me to get them into that slope-intercept form that I can use to graph. And even if I did get it in slope-intercept form, right, we might have some nasty fractions in there and it might be messy. Okay, so because graphing is not always really simple and easy to use, there's other strategies that are actually less work for me, depending on what the equations look like. Okay, when a lot of the time it'll tell you in the directions to use a certain strategy, but then sometimes it's up to you to decide too what strategy you want to use. Okay, so anyway, but substitution, what does that look like? Okay, well, again, substitution, we know that that means to take something and replace it or sub it in, plug it in for that thing that it's equal to, right? And so think about this. Okay, I have these two equations, all right? And so this equation says 2x minus 3y equals 7. Okay, so that's one equation. Then the second equation says x is equal to 4y plus 1. Okay, so think about this. Okay, I know this. So this equation is saying x is equal to this 4y plus 1. Even though that's a group, okay, that is still something that x is equal to. X is equal to this. Okay, and even putting it in parentheses. Okay, so I can substitute this group in for the letter x whenever I see it because this is saying x is equal to that. Okay, and that includes plugging it into x into the other equation. Okay, and so what I'm going to do to start this is actually take this group and substitute it in for the letter x in the other equation. Okay, so look, this first equation, instead of being 2x minus 3y equals 7, okay, that's how it originally was. All I'm going to do, the equation is going to stay the exact same, but all I'm going to do is I'm going to replace the letter x, okay, with this group. All right, so again, the whole rest of the equation stays the exact same. You notice all that I did was I took this letter x and I replaced it with the group that it's equal to. And again, I'm allowed to do that because that's what substitution means. Substitution means if two things are equal, I can take the one thing and sub it in for the other, okay? So that's what I did here. And why is that helpful? Why would I even need to do that, okay? So because you notice, these equations all have two different variables in them, okay? And so when equations have two different types of letters, I can't just solve the equation for one of the letters and say, okay, x is equal to this number, x is equal to 2, x is equal to 5. I can't do that when there's another variable involved. But you notice now that I replaced the x here with this group, if you look at this line right here, now there's no more x's in the equation, right? It's just the letter y. And that's what I want, and that's what I need to be able to start this process of solving this by hand, okay? So that's key, okay? That substitution, that step one is key. Okay, and I'll do it a few more times. So if that's confusing to you how I started that, then don't worry. We'll go through it a few more times. But just solving this out, what is that going to look like, right? Well, I have my equation, right? And we're going back to like unit 1 where we learned to solve equations, right, for a letter. So I would distribute here first, right? So do 2 times 4y is 8y, multiply that 2, and then 2 times this positive 1 is positive 2, all right? And then the rest of the equation just comes down, stays the same. And then what I have here is I have on the same side of the equal sign, I have two different terms with the letter y with them, okay? So I don't have to add 3y to both of these to get them to combine. I can just do straight up 8y minus 3y is 5y. Again, I don't have to cancel those because they're already together on the same side. It's just taking two of the same type of term, combining it, lumping it into one. And so then I write down the rest, okay? So 5y plus 2 equals 7, and then now I can solve it pretty easily, right? I minus this 2, so 5y equals 7 minus 2 is 5. and then I divide both sides by that 5. So y is equal to 5 divided by 5, which is 1. So you might be looking at that saying, oh, great, y is 1. I found my answer. I'm done. Unfortunately, you're not, okay? Because if you remember, solving the system by substitution, solving any system means that I have to find both the x answer and the y answer, okay? Right on the graph, it was super easy. We just found the point, right? So now I found my y answer, so I know it's going to be something comma 1, right? Because that's my y value, but I don't know that x value yet, and that's what I need for a complete answer, okay? But finding the x answer is very easy now that you've found the y answer, okay? So what you do now to find that x answer, right? You know what the y answer is now, right? You didn't know that originally, but you know that now. So what you could do is you could take that number and substitute it into one of your original equations. It doesn't matter which one, okay? Because they're both going to give you the same x answer when you plug in that, right? So you plug in 1 into either of these and for y. So I'm going to just do the second one because that's a little bit simpler of an equation. X equals 4. Instead of 4y plus 1, it's going to be 4 times 1 plus 1. Okay, so x equals 4 times 1 is 4. 4 plus 1 is 5. Okay, so when y is 5, y is 1, x is 5. And what you could do to check your answer is if you plugged in 5 for x and 1 for y, you should get, it should be the same thing. It should work out nice and neat. Okay, but anyway, that's what I get for my answer. When x is 5, y is 1. Okay. So that's solving a system by substitution. I'll do a couple more examples. I hope that makes sense. That's it for this one. So moving on, I'll erase here and do a couple more. Okay, we are back and I put 3 problems up. Okay, 3 problems. I'm going to go through them a little bit quickly if I can. But yeah, let's just work on solving these out. Okay, so that first step, solve the system by substitution. Okay, so you study your equations. Okay, you look to see, do either of them have kind of that variable by itself, right? That's when we can start the process of substitution. Because this is like this equation, y equals 3x minus 1. Okay, so it does have, it's saying y is equal to this group, okay, which is great. So that means that I can take that group and sub it in for the letter y in the other equation, okay. Technically, this one also has y equals that group, so you could go either way, but because y is by itself on both equations. But yeah, so again, it's saying y is equal to this group and y is equal to that group. Okay, so these two equations both have, they're saying y equals this and y equals that. Okay, it's kind of that transitive property that says, right, if the y is equal to both of these things, then these two groups have to equal each other. Okay, or again, you could think, okay, I'm gonna, because y is equal to this group, I'm gonna sub in this group in for y in the other equation. Okay, no matter how you think about it, you end up with 3x minus 1 equals x minus 5. And so now I take this equation and I solve it for x, right? Because there's only one type of variable in this problem now, okay? So, and this is a situation where I have variables on both sides, right? So this minus x, right? I'm going to minus this x from both sides so I can cancel that, right? So that I just have 1x left, okay? So I do that. 3x minus this 1x gives me 2x minus 1 equals negative 5, okay? And now I'm going to plus this 1 to both sides, and I'll be left with 2x equals negative 4, and then, yeah, I'm going to divide by the 2, so x equals negative 2. Okay, and again, so many kids just get to that point and they're like, I'm done, I found my answer. But again, your answer is not complete until you have an x answer and a y answer. So you know that the x value for your answer can be negative 2. But I take that and I sub it in. Okay, I'm going to plug that back in, right? Because I didn't know the x value originally, and now I know it. So I take that negative 2 and I plug it back into either one of my original equations. Okay. Again, I usually just choose whichever one looks simpler, okay? So that second equation originally was y equals x minus 5. So I take that x value, negative 2, and I put it in there for x. So y equals negative 2 minus 5, okay? And so that's going to be y equals negative 2 minus 5 is negative 7. And so that's it. That's my y answer, okay? So when x is negative 2, y is negative 7. And that's it, okay? Now a second one is going to be this guy, okay? So this one is similar to the first one we had, where the top one's a little bit more complex of an equation, right? 4x minus 5y equals 9. Then the second equation, y equals 2x minus 3, okay? So just one of these equations has a variable that's by itself, okay? But I study that bottom equation, right? It's saying y is equal to this group. So I take that group and sub it in for the letter that it's equal to, right? So it's saying y is equal to this. So I take that, replace the letter y in the other equation with that. The rest of the equation stays the same, okay? So I do that, okay? I sub in this in for y. So I get 4x minus 5, but instead of minus 5y, it's going to be minus 5 times this equals 9, okay? So the top equation, the exact same except that group in for y, okay? And again, now this equation now only has one type of variable in it, which is great because now I can solve it for that letter, okay? So I start out by distributing that negative 5. So I do that, and I'm left with 4x. So negative 5 times 2x is negative 10x. And then negative 5 times this negative 3 gives me a positive 15 equals that 9, okay? So it's the same as last one where I have two different terms with x's with them, right? So I can combine those straight up without canceling. So I do 4x minus 10x gives me negative 6x. So negative 6x plus 15 equals 9, okay? And then I start to cancel other terms, right? So minus 15 to both sides, and negative 6x equals 9 minus 15 is negative 6 as well. And then I divide. So negative 6 divided by negative 6 gives me positive 1, right? Because that negative divided by negative, okay? Again, you're not done yet, but you found the key part, right? You found your first variable. So x is equal to 1, okay? Now you need to find that other value, right? And so you take that 1 and you substitute it in for the x in one of your equations. I'm just going to pick the simpler one, which is the bottom one. So I take that 1, I'm going to take it and plug it into that second equation. So that's y equals 2 times 1 minus 3, okay? So y equals 2 times 1 is 2, 2 minus 3, so that equals negative 1. So y equals negative 1, okay? And that's my answer. That's my y value there, okay? So when x is positive 1, y is negative 1. Okay, now if we look at number 3 and number 1 are super similar, right? Where both equations have that y equals the group, right? And so if I look at solving this, okay, I'm going to start it the same way. I'm going to take this group and this group, right? It says y equals both. So I'm going to set the two groups equal to each other, okay? So that's going to be 3x minus 5 equals 3x plus 7. All right, and so that's, again, same setup as number 1. That's start, right? But here, okay, something special is going to happen, just like that happens in a lot of the problems that we do. There's an opportunity sometimes, or there's the possibility that they don't work out as nice as they should, okay? So if I solve this, right, I would try to cancel out one of my x terms. So minus 3x to this side, minus 3x over here, okay? Right? Both sides say 3x minus 3x. So that means they both cancel out, okay? And if you remember, that's the same thing that would happen when we had those special case equations in Unit 1, right? Where all the variables canceled. And so if you remember from that, what's key now is that I look at what's left after I cancel out all my variables, okay? So what's left after I cancel out all my variables is negative 5 equals negative 7, okay? And again, if you remember from Unit 1 as well, when it's a number equal to a different number, right, that statement makes no sense, right? Negative 5 does not equal negative 7. So when it makes no sense, it's going to be no solution. And just because I didn't show you the graphs of these either last time, what would happen if you graphed these two equations is you would actually get two parallel lines. Okay, if you graph these two equations, it would look like that. And right, because on a graph, you look for where do the two lines intersect each other. And two parallel lines never intersect each other. So if you graph these, you'd also get no solution. All right, so that is all for solving systems by substitution. Okay, thanks for following. I know that's a long one. Just one more type of solving with systems, and then we're done. Okay, so good job.